All right, welcome back. And now let's do this example. So we have g of x is equal to 2x squared minus 3x minus 5 divided by the quantity x squared plus 1. Let's go through the steps. So again, we want to find our what? X and y intercepts, right? So y intercept. So again, that is going to be y of, in this case, g of 0. Okay, so g of 0, if we plug in 0 for everything, what do we get? It reduces to the coefficients, right? Or excuse me, to the constant terms, right? So remember that, right? So g of 0 reduces to what? Negative 5. Okay, so we plug in 0, our y-intercept is 0, comma, negative 5. So now let's look at x-intercepts, see if they exist. So x-intercepts is everywhere where g of x is equal to 0. So again, we're looking at the numerator. So we set the numerator equal to 0. When is this polynomial going to be equal to 0? First of all, let's see if it's factorable, right? So I'd use the AC method here. So I get negative 10. And so what are two factors of negative 10 that will give me negative 3 when I add them? Well, here it's going to be what? It's going to be 2 times negative 5. Or 2 and negative 5. Because if I add 2 and negative 5, I get negative 3. Okay, so now let's do the decomposition, right? The method of decomposition, or AC method. So now I'm going to decompose the middle term, so that's going to give me 2x squared plus 2, plus 2x minus 5x minus 5. Okay, now I'm going to group these together, right? I notice I changed this to plus negative. So now I'm going to factor out a 2x here. Oops. Right? Let's factor out 2x here. So that gives me this. And then minus, because I'm going to factor out a negative 5, gives me that. And now I have a common factor again. So I'm going to pull out the x plus 1, and that leaves me left over 2x minus 5. And those are my two factors. Okay, so that's the numerator. So now if I set this equal to 0, then that means x is equal to negative 1, or x is equal to 5 halves. So that means I have two x-intercepts, and it's going to be at negative 1, 0, and the other one is at 5 halves, comma 0. All right, good. Now we can turn our attention to vertical asymptotes. Okay, where are our vertical asymptotes? In this case, if we look at the bottom, remember we want to see if there's any restricted values. In this case, there are no restricted values because there are no real solutions to x squared plus 1 equal to 0. Okay? So there are no vertical asymptotes. What about horizontal asymptotes? Well, horizontal asymptotes, we look at the ratio again. So notice how the degrees are the same, right? So that means there is a horizontal asymptote, and it's at y equals the ratio of the leading coefficients, which in this case is 2. So there's going to be a horizontal asymptote at y equal to 2. All right, good. That which means there's no oblique or nonlinear asymptotes. Okay, so now what's next? So now we're going to determine if it crosses the horizontal asymptote. Okay, so now in this case here, we got to set up a new equation, right? We want to see if it crosses y equals to 2. So we're going to set g of x equal to 2 and see if we can solve it. So now I'm going to multiply both sides by x squared plus 1. So that's going to give me 2x squared minus 3x minus 5 equals, I'm going to multiply both sides by x squared plus 1. So that's going to give me this, right? So now if I distribute the 2, I get that. Now I'm going to move everything over and set it equal to 0. So I'm going to subtract off 2x squared from both sides, but there's a 2x squared here and a 2x squared here. So those are going to cancel. And then I'm going to subtract 2 from both sides. And so what do I end up with? I end up with a negative 3x minus 7 is equal to 0. And so if I solve this, then I get what? I get x is equal to 7 negative 7/3, right? So that means it does cross the horizontal asymptote, and I'm going to put here crosses, crosses at negative 7/3, comma 2. So that's about 2 1/3. So that's at 2 1/3 and comma 2. Okay, so now what else? What's the next thing we look at? We look at symmetry. Okay, well this, you could see that this is not going to give you either, it's not even or odd, because you've got a mixture of even and odd coefficient exponents here. So this is not going to give you, this is not an even and it's not an odd function. Okay, so symmetry is not going to be easy here, so I would just skip it. Okay, so now let's look at plotting at least point along these intervals, right? So let's start figuring this out. Okay, so let's plot out some points. Okay, so now what do we got? 0, negative 5. So 0, negative 5 is right here. Okay. What else? We got a negative 1, 0. And we got 5 halves 0, which is right here at 2.5. Okay. And we got no vertical asymptotes, but we got a horizontal asymptote at y equals 2. So that's going to be right here. So now what we're going to do, oh, and it crosses at negative 7/3. So negative 2 1/3. So negative 2 1/3, it's going to cross right about there. Okay, so let's see what's going on here. Okay? So now, so it crosses here. So it's crossing here, right? Crosses here, crosses down there, and then across here. So it's got to turn back up. Okay? So if we put in -3 here, if we put in -3, what happens here? -3 is going to give us 9, so that's going to give us 18. 18 plus 9. 18 plus 9 is 27. 27 minus 5 is 22. So we get 22 divided by 10. So at -3, it's going up to 2.2. Right, so it's going up. Right, so 9, so -3, so -3, so -3 is 9, 18, 18 plus 9 is 27, 27 minus 5 is 22, so 22 divided by 10 is 2.2, so yeah, it's going up, okay? So now if I want to say, okay, now again, in behavior, it crosses over here. Now as we go to, let's look at something. As we go to -infinity, what's going on? This is becoming, right? So this is going towards what? 2. And as we go to positive infinity, it's going towards 2. So, the fact that it's going up a little bit, so from here, it just goes up to here, so we know that it's going to come back down, right? So it's going off to infinity, going towards y equals 2, and then it's also going towards y equals 2 here. So here's what I think is happening. It's going to go up a little bit, and then it's going to go down here, and it's going to go all the way down here, and then it's going to turn. We don't know where exactly it's going to turn, but it's got to come back up, and it's going to go like that. Okay? So again, we could plot some more points. We could plot a point here, we can plot a point here, plot some more points here if you want, but we got the general sketch of the graph using what we have. Not bad. All right, have a great day.